All right, I'm going to give you like a little informal proof of the chain rule. We've done a lot of complicated stuff so far using it. You'll get a lot of practice. But like we're going to say h of x equals f of g of x. And we're going to use the limit definition where h prime of a equals the limit as x goes to a. And then we have f of g of x minus f of g of a over x minus a. So that's where we start, the stuff in white. And then I multiply by basically what the inner function is, the g of x. And I'm going to do g of x minus g of a over itself. Next line, we do the swapperoo. We switch the denominators, kind of like I showed you doing up above with my shortcut descriptions. And so we've got f of g of x minus f of g of a over g of x minus g of a. And then we have g of x minus g of a over x minus a. And we split the limit, or apply the limit to both of them separately. So the limit of the right one, let's start on the right side here. The limit as x approaches a of g of x minus g of a over x minus a. That's the definition of g prime of a. And you'll remember that rule we had, if it's differentiable, it means the function was continuous there. So the derivative exists at a for g, which means g of x is continuous at a. And since g of x is continuous at a, we know that the limit as x goes to a of g of x has to equal g of a. That was the rules of continuity. And so we're going to take that bit of information, we're going to use it right here. We're just going to say like g of x is y and this is b. So like y equals g of x, b equals g of a. And it changes that limit as x goes to a of f of g of x minus f of g of a. We're going to switch it to the limit as y approaches b of f of y minus f of b all over y minus b. And we're still multiplying it by the g prime a, which we calculated earlier. Now, the limit as y goes to b of f of y minus f of b over y minus b, that is the definition of f prime of b. But b was g of a, so we're going to stick that in there and we get f prime of g of a. So this whole part right here is f prime of g of a. So finally, we've got h prime of a equals f prime of g of a times g prime of a. And since a is an arbitrary value for x, I can just put x back in and we see h prime of x equals f prime of g of x and then times g prime of x. So that's like a little like informal proof of the chain rule. I didn't want to lead with that because that's a lot of stuff going on. I'd rather show you the operations of it. So watch all the videos with the examples and you'll be good. Peace.